dismiss this here. Okay, cool. First test coming up, guys. First test will be on Teams, so you have to have your webcam on. If your webcam is not on, you have to come here and take it here. So I had a student last semester. She said she just totally forgot to turn on the webcam. She came right back the next day and took the test in my office. So make sure the webcam's on, otherwise you have to come back and take the test in person. Some of you actually will be here in person, maybe because of technical issues and no webcam and so forth. Did the tech guy fix share so it's not so touchy? I think the tech guy fixed everything. It seems working fine this morning, so hopefully it should be all good on Friday. As long as I can see you guys somehow, we are okay. Plus on Friday, I'm not really teaching, so I can always have you on my iPad. Either way, that will be fine. So what's going on? Let me go over here. Quiz 1.4 and 1.5, they are due on the 4th. And if I'm not mistaken, I also opened quiz 1.6. So 1.4, 1.5, 1.6 are open, and these are the only 3 quizzes on chapter 1 that are left. So there will be no 1.2, 1.3, or even 1.7. There is no quiz. There was never a quiz for 1.7 anyway. There's the majority of sections do have a quiz, but not all of them have one. So that is it. The chapter 1 video discussion is also now open. So at some point before what, February 7th, go ahead. I know some of you already did it. Click on the video. It's only 4 minutes and 30 seconds. And every little bubble that you see on the screen is a question on the video. So make sure that you get that done as well. I have to go in there and look at your free response questions. So your grade that you're seeing initially, once you submit it, and you have to click on this little submission star here. I haven't answered any, maybe I should. And you click on submit through that way. Test. Like I said, we don't cover 1.2. I'm going to do a couple things from 1.3 today. So the homework is really about 1.1, 1.3, 1.4. Homework right here. So in other words, omit 1.2, which was the least amount of questions. There you go. 1.1, 1, 3, 4, 5, 6, and 7. Here you go. These are your homework questions that you need to turn in on the day of the test. For the homework questions, you have until 11:59. So they can be turned in a little bit later than the test. The test has to be submitted by 12:30. It has to be submitted by 12:30. The test is usually really only scheduled for 1 hour, so I'm giving you a little bit more time to scan the test and then upload it. Okay, so here are your homework questions that need to be uploaded to the assignment folder that says Chapter 1 Homework. And your test needs to go in the Test 1 work. So that will have a due date on the 4th of 12:30. If you have some technical issues, you need to email me and let me know. So here are some announcements on the test. The first one I posted on Monday, that the test will be on the 4th on Teams. Make sure your webcam is working. If you don't have a webcam and you are online right now, either email me and let me know, and you must come here, or people here talk to me, and you must come here as well. But we all cannot do it here because we don't have that kind of room. Here's the link for the homework again. Omit section 1.2. I think I said everything. You can also go in the library and reserve a room. They have computers as well as webcams available for you. So if you're on campus, you can do that right here. Here we go, there it is. What I will do is at 10:45 a.m. on Friday, our class starts at 11, I will email you test 1. So check your email, but I usually always post it in the announcement section as well. So there are 2 places where you can get to your test 1, and then you print out the test, or if you don't have a printer, just copy down the problems on paper and work them out on paper. Scan your completed test, and that one scan, PDF file, that's why I'm leaving the videos here so you can look at that again. And then that test also goes into the assignment under test 1 work. And then I have to go in there and grade them eventually, probably the weekend. Any questions on test? People online, people here? Test 1 will not cover 1.2. There may be one geometry problem from 1.3. We're going to talk about it today. What else? And the rest is really everything we've done, like 1.1, solving linear equations, know what conditional contradiction identity is. What else? In 1.4, inequalities, you have the graphical solution, and the interval notation, and then absolute values and absolute value inequalities. That's basically what the test is all about and what we do today. Now I have office hours still. If you want to talk to me, I have office hour this afternoon on Teams. Wednesdays from 1 to 3 if you want to talk to me, or come and see me Thursday or Friday. Any questions? We're good on the test? Paper, pencil test, nothing out of the ordinary. Okay, the more I talk about that, the less I can talk about math, so let's start talking about this. If you have any questions, put them in the chat. Okay, we are in business. I like it when we are in business. Now I just got to find what I wanted to do today. Let me go through, click through all of this. This is some notes, prior notes. Let me remind you, if we have a negative absolute value, what is the answer? The absolute value of x plus 5 equals negative 27. What is the answer? And if you get this wrong, guess what? I'm going to be mad. No solution. Yes. Okay. We also did, what did we do? We talked about absolute value inequalities, right? We talked about greater than, where we have an or statement, and we talked about less than, we have an and statement, right? We did talk about all of this. Okay. So let's do some problems, a couple more problems. I'm going to summarize, and then we go into 1.3. Does anybody have a question about anything before I move on? Homework, anything? No? Okay. So let's take a look at this problem here. The absolute value of 9 minus 4y minus 2 is greater or equal to 12. How do you plan on solving this? What is the first step here? Did you say subtract or did you add? Right. We got to isolate the absolute value. So the first step would be to bring the 2 to both sides. I'm coming back to you guys online just a minute. That leaves me with 9 minus 4y is greater or equal to 14. So the very first step is always to isolate. If you don't do that, you get the problem wrong. You must isolate to get the absolute value by itself. And now we're going to rewrite it into 2 problems. One problem, drop the absolute value and you write it down exactly as you see it, like so. And the other inequality is 9 minus 4y, and then what do I write? Less than or equal to, we have, no, that's okay. We have to switch the inequality, and the 14 is going to be a negative. We're going the other direction. Actually, here's a lot of changing inequalities. Okay, guys, I'm back. Add 2, yes, thank you. Okay, now what? Now we're solving the inequality. We're gonna subtract 9 here. Negative 4y is less than or equal. Negative 14 minus 9 is negative 23, right? Everybody? Divide by negative 4. Now what happens here? When we're dividing by a negative, what has to happen? Yes, we're going to flip the inequality to greater than or equal to, and this becomes a positive 23 over 4. Okay? Or, if greater than, there's an or in between, we're going to subtract 9 again. Negative 4y is greater than or equal to 14 minus 9 is 5. Divide by negative 4. And again, we have to flip the inequality and make this a negative 5 over 4. So let's take a look at a quick graph. 23 over 4, let's see, it's positive. It's got to be over here somewhere. And negative 5 over 4, the Olympics started already. I was watching some curling this morning. Is right here. I have curled before. That's what I'm talking about. Okay, moving on. So, 23 over 4 greater than or equal to, I need a bracket. I'm going to the right. Or less than or equal to, we have a bracket and we're going to the left. The interval notation would be, hold on, we got more coming in. The interval notation would be what? Who can tell me? It is a union, that's for sure. There's a union in between. Negative infinity to negative 5/4, and 5/4 is a bracket. Union what?
Union and then bracket and then 23 over 4
To
to
infinity. That is correct. Guys, any questions here? Yeah, you say that no. Let's wait till you get the problem on the test. Same type of problem. I don't want to do this now. Let's do another fraction one. Have we done this already? Okay. The reason I'm asking, I'm literally teaching 3 intermediate algebra classes. So let's do this one together. What is the first step? Well, not quite. We got to isolate first. So we want to add the 2 to both sides. Absolute value of x plus 3 over 2 is less than or equal to 6. And we're still not multiplying by 2. The first step, the next step should be to rewrite the problem. Now to rewrite the problem, we're splitting it into 2, drop the absolute value, and this would be x plus 3 over 2 is less than or equal to 6, and x plus 3 over 2 is what? People online, what do we have here? What do we need? We switch the sign. That makes it greater than or equal to -6. So greater than or equal to. And now is the time where we go ahead and multiply everything by 2. Yes, that could have done probably a step earlier, but sometimes students make mistakes when they do that. So we're going to do it right now. The 2 reduce, and we are x plus 3 less than or equal to 12, and x plus 3 greater than or equal to -12. The inequality is pretty simple. Subtract 3. X is less than or equal to 9. And x is greater or equal to -15. Okay, now we have to graph it. -15 here, 9 over here, and let's see what happens. Less than or equal to 9, bracket, going to the left. Greater than or equal to -15, also bracket, going to the right. Now, ladies and gentlemen, this is an and statement. Where do you see, they're both the same color, let's make a different color. Where do you see the pink and the green? Together, together, together. That would be our interval notation. So what do I write? Interval notation, pink and green at the same time?
It would be bracket, -15, and then non-bracket.
And then 9 bracket, right. Here you go. Yes, Alexander, thank you. Here you go. Okay. I want to talk about these 3 problems, and then we're done with 1.7. Let's see what you think. What do you know about the first one? The first one on top, the absolute value of x plus 2 equals a -3, and people feel free in the chat room. What do you know about this as I'm walking around? Absolute value x plus 2 equals -3. No solution. You don't have to do anything. No solution. Is the same true for absolute value inequalities? What do you think? It's, that's the same hold true for these inequalities that I wrote down here. Are they also no solution, or do you think there's something else going on here? How about, let's take a look at the first one. The absolute value of x plus 2 is greater than negative 3. What do you think the answer here is? I mean, we could do the problem, rewrite it, and see what happens. How about if I put in a negative 1,000? Negative 1,000 plus 2 absolute value, is that greater than negative 3? Yes? Chloe says yes. Well, negative 1,000 plus 2 is a negative 998 absolute value. What is the absolute value of a negative 998? A positive 998. Is that greater than negative 3? Yeah. So I went all the way to negative 1,000. How about if I plug a negative million in? It still would be greater than negative 3, right? Once I take it out of the bars. Now, what about a positive number? So we can go all the way in the negative here. Negative 1,000 we know works. How about a positive 1,000? Or a million? If I plug in a million for x, I get 1,000,002. Is that greater than negative 3? Whenever you simplify something from an absolute value, what is the sign of that number once you take it out of the absolute value? That's always positive. And isn't a positive, so this will always be positive no matter what when you simplify it. Isn't a positive number always greater than negative 3? Yep. So the answer here, if we have a greater than negative 3, is all real numbers, negative infinity to infinity. All real numbers are a solution because no matter what you plug in for an absolute value, be it negative, once you take it out of it, it's greater than negative 3. Everything is greater than negative 3. So for this inequality, we have all real numbers. Now let's take a look at the absolute value x plus 2 is less than negative 3. Less than negative 3. Is it also all real numbers, or is it no solution, or what's going on? Exactly, you said it. An absolute value, whatever we plug in here, is always positive. And is a positive number less than negative 3, question mark? No, that's not going to happen. So in this case, it's no solution. So you have 2 no solutions and 1 all real numbers. Let me summarize that if I can. Summary. So if I have the absolute value of x equals, and I'm going to just use a negative number, let's say negative 4, that would imply no solution. The absolute value of x greater than negative 4 is negative infinity to infinity, all real numbers. The absolute value of x less than negative 4, less than a negative number, is also no solution. So these are our absolute value inequalities when the result on the right-hand side is negative. if you have the absolute value of x is greater than, let's say, 4, then this really changes into an or statement, -4 or x is greater than 4. And the interval notation would be -infinity to -4 union 4 to infinity. If you have an absolute value that is less than 4, then you split it into x less than 4 and x greater than -4. And the interval notation would be between the two numbers from -4 to 4. There you go. So this is kind of a summary of inequalities, absolute value inequalities. Questions, guys? This is 1.7. Okay, now, then we're gonna go into 1.3. 1.3 is geometry. I'm gonna say geometry and literal equations. And I'm gonna talk about literal equations first. Does anybody know what a literal equation is? What is a literal equation? We gotta go. Okay. Yes. Literal equation. What is it? Any thought? An equation actually with more than one variable. A formula. A formula is a good example of a literal. Formula is a good example of a literal equation. More than one variable. More than one variable. And of course, speaking of formulas, we all know the formula for the area of a rectangle, length times width. You don't have to memorize formulas, they will be given to you. So let's say here's the width and here's the length. The area, of course, is everything in here. That's the area. So when we're talking about literal equations, sometimes you're being asked to rearrange the equations without any numbers present. So if you have the formula A is L times W, and you are supposed to solve for L, how do you do that? In other words, get L by itself. People online, how do we get L by itself? We want to solve, we want to rearrange this, yes, we want to rearrange this equation, Rodney, right? Yeah. For L, so Rodney says we need to divide, yes, and Danielle says that too, because this is L times W, so the brother of multiplication is division. So we go ahead and we divide both sides by W, and the area divided by the width gives us the length. Yes. So we have to see what are our original operations, and then we have to do the opposite. Another famous formula, since we're talking about a rectangle, is the perimeter. The perimeter is when you add up all the sides, so you have another W here and another L there. So the formula for the perimeter is 2L plus 2W. Again, you don't have to recite the formula. If you have a problem like this, the formula will be given to you. Now, we're going to solve this perimeter for W. For W. Solve for W. Any thoughts of what we need to do first? So we want to get the W by itself. We're going to have to isolate. Yes? Not yet. Because the 2L is a term by itself, that means the 2L has to be moved over first. So we're going to say minus 2L minus 2L. P minus 2L equals 2 times W. Rodney, now it's your turn. Now we're going to divide by 2. So always isolate the entire term first and then you do the division. I mean, you could divide by 2, but then we don't want to do that. And if we divide by 2, another common mistake students make, because you actually have to do more than I want you to, you're doing more than I want you to do. Sometimes students write it like that, P minus L. Where's that coming from? Well, you cross out the 2's and all you have left is P minus L, which is not correct because that 2 in the denominator is over the P as well as the 2L. So you don't even have to do that. You just have to write W equals P minus 2L over 2. Leave it like that, otherwise you probably do more harm to the problem. Here you would have gotten full credit. Here you would have gotten full credit, but if you would have written P minus L, I would have taken points out, because now you're doing it wrong. So be careful. Okay, let me pick another problem. So on page 33, I'm going to pick number 47. 47 is a volume problem, equals 1/3 the base times the height, and you are supposed to solve for big B, big bird, for the base. This is the formula for cylinder, but again, that's beside the point. Okay, any thoughts, people? What do you think we should do here? But subtract 1/3. What operation is between the 1/3, the B, and the H? It's multiplication, so I can't really undo multiplication with subtraction. That's not possible. So what else? What should we have a fraction. What have we done so far with our fraction? Get rid of them, right? So what do we need to do first? What's the LCD? 3. We're going to multiply everything by 3 on either side. So that leaves you with 3V equals base times height. Looks so much better now. Last step, people online, we got to get B by itself. What do? Oh, Danielle already said divide by H. So B equals 3V over H. Guys, questions? Any questions? Now, a formula you all may be familiar with is y equals mx plus b. We need this formula next chapter, in chapter 2, it's the slope-intercept form. That is beside the point right now. Here's our formula, and I want you to solve for what? M. Why not? Solve for M. Any thoughts? Solve for M. First step is to subtract the B. We gotta get rid of everything that doesn't include the M. I'm sure Danielle is wanting to say that. So we're going to subtract the B, and then Danielle is already one step ahead of me. Yes, you are correct. So on the left-hand side, we have y minus b equals mx. And now Danielle says we're gonna divide by x both sides, and again, just leave it like so. M is equal to y minus b over x. Don't be fancy, that's it. At least not yet. Now a similar problem. Next chapter, if I look at 54, I'm going to give you an equation with two variables. And in chapter 2, I probably ask you what is the slope, what is the y-intercept. So that means this equation, we're going to practice it now, has to be solved for y. It has to be in the form y equals mx plus b. So we got to solve for y. How? Hold on a second. Let's see, online people, are you with me? Are you awake? I need to start some forms. So see if you're, other than Danielle. I know Danielle's awake. Oh, that was Nicholas earlier. Okay, Nicholas. You said it, yes. Nicholas is awake too. Okay, first thing Danielle says, Rodney, what do you say?
Subtract 5x.
Subtract 5x. You both are correct. That leaves me with a negative 7y, and since we want to get ready for chapter 2, y equals mx plus b, we're going to write the 5x first. The negative 5x, that is. Nicholas is awake. Yes, I know. You've been answering. Okay, and the next step is to divide by negative 7. Now you want to write everything over negative 7. Because sometimes you can actually reduce, which makes it easier if we had to graph this and do all kinds of stuff to it. Y equals a negative divided by a negative is a positive 5/7 x. And then minus 15 divided by 7 is a 15 over 7. There you go. That's it.
Question.
Yes.
Because you had just written it y equals 5x. Oh wait, never mind. Because you had just put the whole thing over, under.
You could have written it like so.
Okay.
5x minus 15 over 7. Yes. Or you could have said y equals negative 5x plus 15 over negative 7. That would have been correct as well. So all three of these are actually say the same thing. Yeah. Yep. Cool. Okay. Now let's talk a little bit about geometry. Not my favorite subject, I have to say. I could tell you a story when my son was taking geometry online, but I'm not because we don't have that much time. But he thanked me afterwards that he had to do it all himself because I'm not a geometry person. Okay, so some geometry problems are about angles, and we have two types of angles. We have what is called a supplementary angles or complementary angles. Does anybody know anything about this? Supplementary and complementary angles. Let's talk about complementary angles first. Complementary angles are two angles that add up to what? 90 degrees. So if we had two angles here, let's call that angle A and this angle B. And you see my little square box here, that means we are dealing with a right angle, which is 90 degrees. So two angles complementary if the sum of the two angles measures 90 degrees. There you go. Where there are complementary angles, there are supplementary angles, and supplementary angles come from a straight line. So if you have a straight line and you divide this into two angles, let's say here's A and here's angle B, then both angles have to add up to what? 180. So two angles are supplementary if the sum of the two angles measures 180 degrees. So we have 90 degrees. 90 is complementary. That's how, well, back in the day, how I remember things is looked by alphabet. C with 90 with the smaller one, because C in the alphabet is before now S, so S with the larger one. Anyway, and the sum, let's say we have a triangle. Beautiful triangle, and we have angle A, B, and C. A triangle consists out of three angles. What is the sum of all three angles in a triangle? 180. Has to be 180 because a triangle is really nothing else than half a rectangle. Half a rectangle has 490 degrees, so that would be 360. Cut the rectangle in half, you have two triangles, that makes it 180. And that's where this all came about back in the day. So the sum of all angles within a triangle measure 180 degrees. Here you go. Okay, now let's take a look at some word problems here that we have. Let me take a picture. That way I don't have to write down. So the simple one first. What time is it? Oh yeah, we got lots of time. Okay, cool. Okay, that's on page 32. These are some typical problems on geometry. Let's take a look at 19 first. 19 and 20, you already have kind of the graphs given, which is kind of hopefully easy. So it says number 19, solve for x and find the measure of each angle. So if you cannot read it, let me write it down. We have a 7x minus 1, and we have a 2x plus 1 over here. So what do I do here? What must I do in order to figure out what x is?
Do 7x minus 1 and then plus 2x plus 1 equals 180.
You do 7x. Mark, I just saw your chat. Hold on, I'm getting to it. What do? I do 7x minus 1.
Yeah, and then plus 2x plus 1 equals 180.
Plus 2x plus 1 equals 180. That is absolutely correct. So go ahead and finish this. Let me see what Mark says. Isn't supplementary 90 degrees and complementary 180? No, Mark, it's the other way around. Complementary are 90 degrees and supplementary are 180 degrees. And if you look in the book on page 27, you can see that. Yes, you have them mixed up. Okay, Danielle said to add to 180. Yes, add them and add to 180. Yes, Alexander, you're all correct. Okay, combine like terms. 7x and 2x is 9x. The minus 1 and the plus 1, they cancel each other out. So 9x equals 180 divided by 9. That gives x equal to what? 20. 20. Now, if a problem like this is on a test and students stop here, you may get a quarter of a point, even so you have the problem right. Why?
It's not asking you to find x, it's asking you to find the sum of the angles.
Right, you have, yeah, Nicholas, you're right. Yes, you haven't found the angles yet. You just found the value of x, but it's asking find the measure of each angle. So now you actually have to plug it in. Plug it in. 7 times 20 minus 1. 40 minus 1 is 139 degrees. And 2 times 20 plus 1 is 41 degrees. So 41 plus 139 indeed is 180. Now for number 20, again, it's kind of simple. You have your graph, you add them both, you set them up, you add them to 90. I don't want to do that. Let's take a look at number 18. Number 18 says two angles are supplementary. We have to come up with an equation. So two angles are supplementary. What does that mean? Two angles are equal to what? 180. So here we go. We already have kind of a setup. One angle measures 12 less than 3 times the other. Now, that's why we're actually doing this again in chapter 3. In chapter 3, we are dealing with two variables, x and y, which makes it kind of easier. Here, we're going to have to write that equation in terms of just one variable. So, any thoughts on that? We just want to use the variable x. Yes, Danielle, you are correct. So, one angle is just plain simple x. We don't know anything about the one angle. But we know that the other angle is 12 less than 3 times the other. So the other we know nothing about, that's our x. How do I represent what it says here? 12 less than 3 times the other. Yes?
3x minus 12.
You got it. 3x minus 12. would be the representation. Yes, Nick, you got it. Would be the representation for the second angle. So the first angle here always has to be x. The other angle is 3x minus 12. Combine like terms, so x plus 3x is 4x. 4x minus 12 is 180. Add 12, and please have a calculator handy. 4x equals 192. Divide by 4. X is equal to
48.
my favorite number, 48. And again, we're not done. So one angle is 48 degrees. The other one is 3x minus 12. 3 times 48 minus 12. 120, 144 minus 12, 132. 132 plus 48 is indeed 180. How do you like that? Let's do one more. Number 17. Two angles are complementary. Oh, what does that mean? Two angles are complementary. That means they add up to 90, right? One angle is 5 times as large as the other angle. One angle is 5 times as large as the other angle.
5x.
Plus
X.
x, you got it. The other angle, again, as we know nothing about, that's your x, and the second angle is 5 times as large. So if I continue here, we have 5x plus x equals 90. 5 plus x is 6x equals 90. Divide by 6. X is equal to 15. You can't stop here. That is one value of the first angle. The other one is 5 times 15, which is 75. So these are your two answers. We're going to do the same problem again once we get to chapter 3 when we work with two variables. Any questions so far? Let me actually, let's see if I can do that without breaking the system. No, I don't want to do anything here. Each content. Each chapter has a review that you don't have to turn in, but it's a good resource. Move this out of the way. I'll move this over here. I don't really need it. It's a good resource for you to practice, and under chapter 1, here's the chapter 1 review. We have some time, so let's take a look at some of these problems. The first part is just on some definitions. Conditional. Somebody give me an example of a conditional equation. Conditional equation. Conditional equation. Give me an example. What?
4x. Okay, well, I'm sorry, that's
If you said something.
Okay, let's start with 4x.
Yeah, contradiction.
4x, Tony Ann? Conditional equation. If we start with 4x. Yes, Alexander, the answer to your question is yes. You could have just divided.
I don't know how to come up with an example.
Equals 20. 4x equals 20. That would be an example of a conditional equation, because what happens here is if you divide by 4, you get x equals 5, and you come up with a solution that makes this equation a true statement. So an identity, can somebody come up with an example of an identity? Identity? People online?
Is that one where it's like x plus 3 equals negative x minus 3?
No. Just like the word says, if we have an identity, x plus 3 has to be equal to x plus 3. Has to be exactly identical. That would be an identity, and when you have an identity, the solution is all real numbers. No matter what you plug in here, it will always hold true. Contradiction. Give me an example of a contradiction.
That would be like if we said 1 plus x equals 2 plus x.
1 plus x equals 2 plus x. That is correct. That would be a contradiction. Nicholas is saying 4 equals 7. That is also a contradiction. If you were to solve it, what you're left here is 1 equals 2, which now means in terms of solution, we have no solution. Okay, cool. Just what instructors sometimes perceive are the easiest question, like just make up an example, sometimes don't seem to be that easy. Okay, press. Okay, what else do we have here? Okay, we haven't done that, so no worries here. Give an example. We kind of did that now. What is the sum of the angles of a triangle? Just did that. What is the degree measure of a right angle? Complementary angles. Complementary angles add up to 90. Right, Nick? And 2 supplementary angles add up to be what? 180, right. Okay. Don't worry about it. Let's do this fraction one. You like fraction? Okay, let's do number 24. Let's practice. How would you solve this?
First find the LCD.
The LCD of this problem is 15. Find the LCD, which is 15. You are correct. Now we're going to multiply everything by 15. And don't forget the -2. The reason why we do this is to clear the denominator. 3 goes into 15 5 times. So that's leaving me with 5x minus what? 5 goes into 15 3 times minus 9, 3 times 3, don't forget that, equals -30. Okay, we're going to add 9. 5x is equal to -21. Divide by 5. X is -21 fifths. Done you are. Beautiful. There you go.
Would the right answer also be a mixed fraction?
Yes. Yeah. I think I talked about it. We're trying to keep the fraction answers as an improper fraction, but of course I will not mark it wrong if you were to change it into a mixed number or even a decimal. But try not to do that. Okay, here's another one. Oh, you want to do this one, or which one you want to do, 27 or 28? People online, let the people online decide. Which one you want me to do, 27 or 28? Whoever's first gets first dibs. 27, okay. 27, the fraction one. So, help me out. What is the LCD? LCD is 20. 20, 20, 20, 20. So 4 goes into 25 times. 5 times 3 is 15, plus 10 goes into 22 times. 7 times 2 is 14y. Equals 20 goes into 21 times, so you have a 7 minus 1 and 4, so minus 8y. This is what we got. And now I'm going to move the 8y to the left. (15 plus 22y equals 7. I think somebody emailed me the answer key of this chapter 1 review. If I find it, I will post it. Subtract 15, and we have 22y equals negative what? Negative 8 divided by 22. Y can be reduced to negative 4 over 11. Beautiful. How do you like that? Let's see, we got time for one more. Let's see what else we got here. Absolute value. Oh, what's the answer to 33? You better believe it. Why is it no solution? Because it's equal to a negative number. And these are all word problems that we haven't done, so you don't have to really worry about this one. Here's an absolute value. How about 41? Last one. Let's take a look at 41. What do you want me to do first? No, this absolute value. We can distribute. First, you're going to subtract the 8. Yes, Anissa, you're right. So we have negative absolute value of x plus 4 is greater or equal to negative 6. Now what do we do? Divide by negative 1. Oh, here's a whole bunch of stuff going on. So we have the absolute value of x plus 4 is what? Less than or equal to 6. So it's not negative anymore. Now we're going to have to rewrite it into x plus 4 less than or equal to 6. And because it's a less than, x plus 4 greater or equal to negative 6. Which order you write them makes no difference. So you can write the negative 6 first. Subtract 4, x is less than or equal to 2, and subtract 4 here, x is greater or equal to negative 10. So if you were to graph this, that means this solution is between -10 and 2, and they are both having a bracket looking like so. In between those two. Greater than -10 goes this way, less than 2 goes that way. The interval notation is -10, comma 2. Done you are. And like I said, whatever we have not covered in class, you don't have to worry about it. But discard. There is 42. Let's just set it up. I don't want to solve it. We have two angles that are complementary. That means they are equal to 90. One is always x, has to be. The other one is twice another plus 30. 2x plus 30. So these are your two angles. You can go ahead and you solve it. I don't want to solve it right now. Any questions, guys? Test on Friday. Similar to what we did in class, nothing out of the ordinary. There will be nothing on the test that is, oh, I got you. I don't like those questions anyway. It is, if you've done the homework, worked on these problems, you should have absolutely no problems on the test. Again, I will post it 15 minutes before 11 in Falcon Online, send you an email. Print it, complete it, turn your webcam on before. Go on Teams, turn your webcam on, complete your test, and then scan it, upload it, and have a good weekend. If you have questions between now and then, of course, you know where to find me. There's an office hour this afternoon. Just to be clear, you want all of chapter 1's homework turned in together and uploaded the same day as the test via scanning and uploading through a PDF. Nicholas, that is absolutely correct. Yes, beautiful. Yeah, I'm just reading the chats here. So if you guys don't have anything, have a good afternoon. I'll be online between 1 and 3. Elijah, sorry, I had to go. Yeah, that will be fine. I recorded everything, and I will stop the recording now, and I will post it later, and you can